Hello guys, today's session is about the n factor and equivalent weight calculations. So here in this session, we will be discussing about the n factor calculation in case of acids, base, elements, ions, and in the case of salt. So let us start with the acid part first. N factor of acid is equal to number of replaceable hydrogen atoms per acid molecule. For example, in case of HCl acid on dissociation, it gives one H plus ion and one Cl minus ion. So number of ions formed on dissociation of one molecule of HCl is known as the n factor of acid. So here n factor of acid, this HCl is equal to 1 because it gives only one H plus ion. So n factor of HCl is equal to 1. So n factor of acid is also known as what? It is also known as a basicity. N factor of acid, it is also termed as basicity. Second example is HNO3 molecule, HNO3 acid. HNO3 acid also on complete ionization, it gives one H plus ion plus one nitrate ion, one H plus one nitrate ion. This is the actual structure of HNO3 molecule. In HNO3 molecule, OH group is bonded to nitrogen atom, and this hydrogen atom from HNO3 is acidic. So on dissociation of this HO bond, what will happen? On dissociation, we'll get H plus ion plus nitrate ion formation takes place. So one HNO3 molecule on dissociation, it gives one H plus. It gives how many H plus? It gives one H plus. So n factor of HNO3 is also equal to 1. So HNO3 is also it is also known as what? Monobasic acid because its basicity is 1. Next example is H2SO4. H2SO4 acid. H2SO4 on dissociation, let us find how many hydrogen ions can form on dissociation of one H2SO4 molecule. H2SO4 on dissociation, it gives 2H plus ions plus sulfate ion. Structure of H2SO4 is, this is the actual structure of H2SO4. Two OH groups are bonded to sulfur atoms and two hydrogen atoms are there. Both these hydrogen atoms are acidic because these hydrogens are attached to the more electronegative oxygen atoms. Now on dissociation of this bond, oxygen, hydrogen, on dissociation of these two bonds, what will happen? We'll get 2H plus ions in the solution, plus there is a formation of sulfate ion formation takes place like this. Sulfate ion formation takes place. So here one H2SO4 molecule, it gives 2H plus ions. So its basicity is 2. So n factor of H2SO4 is 2. It is known as what? Dibasic acid. It is known as dibasic acid because it gives 2H plus ions in the solution. Next example is oxalic acid. Oxalic acid. This is a structure of oxalic acid. Two carboxylic acid groups are present in oxalic acid. Now this oxalic acid on ionization, here two carboxylic acid group on dissociation gives how many H plus ions? So this bond on dissociation, these two bonds on dissociation will get 2H plus ion in the solution. 2H plus ion plus oxalate part remain as it is. Plus this oxalate part, oxalate minus oxalate ion, that is C2O4 minus 2 ion. Oxalate ion is C2O4 minus 2 ion. So here one oxalic acid molecule, it gives 2H plus ion. So its n factor is equal to 2. N factor is equal to 2. Next example is hydrogen sulfide H2S. In hydrogen sulfide, this is a structure of hydrogen sulfide H2S. On dissociation of this sulfur hydrogen bond, on dissociation, it gives how many H plus? It gives total 2 H plus ions in the solution. So its N factor become N factor is equal to 2. Hydrogen sulfide is N factor is equal to 2, and hydrogen sulfide is also a diabasic acid because on ionization it gives total how many H plus? It gives 2N plus 2 H plus ions, so its N factor is 2. Hydrogen sulfide is also diabasic acid. Next example, hypochlorous acid HClO is a hypochlorous. Name of this compound is hypochlorous acid. Next example is HClO2, that is chlorous acid. Chlorous acid, chloric acid. HClO3 is known as a chloric acid, and perchloric acid HClO4 known as a perchloric acid. Perchloric acid. So here, due to the presence of only one H plus, only one hydrogen atom, so all these four acids are monobasic acids. N factor is equal to 1. N factor is equal to 1. Monobasic acid, N factor is equal to 1, because these acids on dissociation gives only one H plus ion per molecule. Next example is phosphoric acid. Phosphoric acid. Phosphoric acid formula is H3PO4. H3PO4, and the structure of phosphoric acid is 3 OH groups are bonded to the phosphorus atom plus one double bonded oxygen is there, which is directly attached to the phosphorus. Now here, how many H plus ions are there? How many replaceable H plus? Total 3. 3 replaceable H plus ions, and due to the presence of 3 replaceable H plus ions, this molecule on dissociation gives phosphate ion. This first oxygen and hydrogen bond cleavage takes place. So we'll get a phosphate ion. Along with the phosphate ion, there is a formation of, along with the phosphate ion, what will happen? There is a formation of this 3H plus ion formation takes place. 3H plus. So due to the formation of this 3H plus, phosphoric acid N factor is 3. It is known as a tribasic acid. Tribasic acid. Tribasic acid. Okay. Next example is phosphorus acid. Phosphorus acid. Phosphorus acid. Now, in case of phosphorus acid, formula of phosphorus acid is H3PO3. H3PO3, and the actual structure is, in actual structure there are two OH groups which are directly bonded to phosphorus. One hydrogen is also attached to the phosphorus, and one double bonded oxygen plus oxygen phosphorus bond is present. Now here, how many ionizable hydrogen atom or how many hydrogen atoms can form in the solution? Only two hydrogen atoms, only two bonds. This phosphorus oxygen bond cleavage takes place, and due to the cleavage of these two bonds, it gives 2H plus ion in the solution. So there is a formation of 2H plus. So we'll get 2H plus ion in the solution. So due to the formation of these 2H plus ion in the solution, its N factor is 2. Phosphorus acid N factor is 2. It is a dibasic acid. Dibasic acid. Next example is hypophosphorus acid. Hypophosphorus acid. Hypophosphorus acid formula is H3PO2. Actual structure is 3 phosphorus hydrogen bonds and 1 OH phosphorus bond plus 1 double bonded oxygen phosphorus bond is present in hypophosphorus acid. Hypophosphorus acid on dissociation, it gives only one H plus. It gives only one H plus ions. Hence, its basicity is equal to 1. So its N factor is equal to 1. It is a monobasic acid because it gives only one H plus ion, only one this H plus ion. So its basicity is equal to 1. Basicity is equal to 1. It is a monobasic acid. N factor of the hypophosphorus acid is equal to 1. Next example is pyrophosphoric acid. Pyrophosphoric acid. Pyrophosphoric acid, the formula is H4P2O7. H4P2O7, and the actual structure of the pyrophosphoric acid is, this is the structure of phosphoric acid. So let us add two phosphoric acid molecule and remove one water molecule. So we'll get pyrophosphoric acid. Add these two phosphoric acid. These are the phosphoric acids. Let us add these two phosphoric acid and remove one water molecule. Remove one water molecule. So we'll get pyrophosphoric acid. Okay, this is the actual structure of pyrophosphoric acid. There is one bridged oxygen atom is present between two phosphorus atoms. So this is the actual structure of pyrophosphoric acid. Now let us find how many replaceable H plus ions are there. Total replaceable H plus 1, 2, 3 and 4. So pyrophosphoric acid, when it is added into water, what will happen? It will dissociate. So this H4P2O7 on ionization, it gives 4 H plus ion plus pyrophosphate ion formation takes place. So due to the formation of these 4 H plus ion in the solution, N factor of the pyrophosphoric acid is equal to 4. This pyrophosphoric acid is known as what? It is known as a tetrabasic acid. Tetrabasic acid. Next example is boric acid. Boric acid. Boric acid. Formula boric acid is BOH of thrice. It is also written as S3BO3. S3BO3. Structure of boric acid is boron is a central atom and 3 OH groups are directly attached to the boron. So here 3 OH bonds are present in boron molecule. So we are expecting its N factor 3, but actual N factor is not equal to 3. Its N factor is not equal to 3. Why its N factor is not equal to 3 when boric acid acts as an acid? Because let us find first how many electrons are there around the central boron atom in boric acid. So number of electrons around the central boron atom is equal to, there are total 6 electrons are there. Okay, 6 electrons, there are total these 6 electrons around the central boron atoms. So this boron has incomplete octet. And because of this incomplete octet, it required 2 more electrons to complete its octet to achieve the stability. So how this boron will achieve stability? When boron, when it is treated with a base, for example, when it is treated with a base like NaOH, then what will happen? This negatively charged OH minus ion, negatively charged OH minus ion, it attacks on central boron. It attacks on central boron, and there's a formation of new bond formation takes place. There's a formation of new bond, that is coordinate bond formation takes place. Actual bond is coordinate bond. Coordinate bond formation takes place. Coordinate bond formation takes place like this. Now let us replace this coordinate bond by using covalent. Let us convert this. So the structure become OH, boron, OH. Here OH minus is a donor atom. So assign the charges to these donor atoms. Negative charge is already there. Now donor atom, which one is a donor atom here? OH. So assign positive charge to the donor and negative charge to the acceptor atom. Now this plus and minus getting cancelled. So actual structure is BOH of 4 minus 1. So there is a negative charge on boron. Negative charge on boron. So this structure also can be written as BOH of 4 minus 1. BOH of 4 minus 1. Okay, so here one boric acid molecule, it reacts with only one OH minus ions. So there is another definition of N factor of acid. N factor of acid is known as what? Basicity, and this basicity is also defined as basicity. We know that the basicity is nothing but what? Number of replaceable H plus ions, and the basicity of acid is also defined as number of OH minus ions, number of OH minus ions required to neutralize, required to neutralize one acid molecule, one acid molecule. So here this one boric acid molecule is neutralized by only one OH minus ion, only one OH minus ion, only one OH minus ion neutralizes one molecule of boric acid. Hence the N factor of boric acid is equal to 1. It is a monobasic acid, it is a monobasic acid. Okay, so N factor of this boric acid is equal to 1. It is a monobasic acid, monobasic acid. Okay, so this is all about N factor calculation in case of acid. Now we'll be discussing how to find equivalent weight of acid. So there is a formula to find its equivalent weight. Equivalent weight is equal to, formula to calculate equivalent weight of acid. Equivalent weight of acid is equal to its molecular weight divided by molecular weight of acid divided by N factor divided by basicity. N factor of acid means what? Basicity, basicity of acid. Now let us find so N factor calculations. We already calculated the N factor of acids. Now find the equivalent weight. For example, in case of HCl, equivalent weight of HCl, we know that it's molecular mass. Let us find molecular mass first. Molecular mass of HCl, hydrogen 1, chlorine 35.5. So its molar mass becomes 36.5. Okay, so molecular weight 36.5, and it's, we know that its N factor is 1, basicity 1, so its equivalent weight become 36.5. Next example is H2SO4. Equivalent weight of H2SO4. H2SO4, let us find molar mass first. 2 into 1, 1 is the atomic mass of hydrogen, plus 1 into 32, 32 is atomic mass of sulfur, plus 4 into 16, 16 is the atomic mass of oxygen. Total becomes 98. So equivalent weight of H2SO4 is equal to, equivalent weight of H2SO4 is equal to 98 divided by 1. 98 divided by N factor is 2, not 1. H2SO4 N factor is 2. Equivalent weight is equal to 49. Next example is oxalic acid, H2C2O4. Let us find molecular mass first. 2 into 1, 1 is atomic mass of hydrogen, plus 2 into 12, 12 is atomic mass of carbon, plus 4 into 16 atomic mass of oxygen. Total is equal to 2 plus 2 into 14, 2 into 12, plus 16 into 4, so which is equal to 90. So 90 is a molar mass of oxalic acid. So equivalent weight, its equivalent weight is equal to, equivalent weight of oxalic acid H2C2O4 is equal to 90 divided by 2. We know that N factor of oxalic acid is 2. So its equivalent weight is equal to 45. So by using this formula, we can easily calculate equivalent weight of acid. Equivalent weight of acid is equal to its molecular weight divided by N factor. In case of acid, we know that N factor is its basicity. Now the basicity, two different definitions are there. If the acid contains replaceable H plus ions, then basicity is termed as number of hydrogen atoms formed on dissociation of one molecule of acid. But if there is no H plus ion or acid is not capable to lose H plus, then we can define basicity in another way. Like a basicity is defined as number of OH minus ions required to neutralize one molecule of acid. So the second definitions we will be using for this boric acid N factor calculations, right? Yeah. Now, so this is all about N factor and equivalent weight calculations in case of acid. In case of base, N factor is equal to N factor of base is equal to acidity. Acidity of base. Now, acidity means what? Acidity means number of OH minus ions formed. Number of OH minus ions formed per base molecule. Per base molecule, or it is also defined as, there is another definition also, number of H plus ions, required to neutralize one base molecule, for example, NaOH base. NaOH, when it is added into water, what will happen? It gives Na plus ion plus OH minus ion in water. So one NaOH gives one OH minus, so its N factor is equal to 1. So NaOH is a monoacidic base. It is known as what? Because its N factor is 1, so it is known as monoacidic base. Next example, similarly, calcium hydroxide. Calcium hydroxide on added into water, it gives calcium 2 plus ion plus 2 OH minus ion, right? So this calcium hydroxide gives 2 OH minus, hence its N factor is equal to 2, and it is known as a diacidic base. Similarly, next example is aluminium hydroxide. Aluminium hydroxide, it will give 3 OH minus ion, 3 OH minus plus Al3 plus, so its N factor is equal to 3, right? N factor. So aluminium hydroxide is known as a triacidic base. So if the base contain OH minus ions, then depending upon the number of OH minus ions formed in the solution, we can easily calculate its N factor. Now, if the base do not contain OH minus, then how to calculate its N factor? For example, in case of ammonia base, when ammonia acts as a base, we know that there is one lone pair on the nitrogen atom. Now, there is no OH minus ion, so we cannot use the first definition of acidity calculation. Now, we'll be using the second definition, that is number of H plus ions formed on, number of H plus ions are required to neutralize one base molecule. So, let us apply the second definition. On NH3, there is only one lone pair, so it's required only one hydrogen for neutralization. This lone pair, it takes one proton H plus, and there's a formation of NH4 plus ion. So one ammonia molecule neutralized by one H plus, hence its N factor is equal to 1. Next example is phosphine, PS3. In PS3 also, there is only one lone pair, so PS3 also required only one H plus. It gives corresponding ion PH4 plus ion. Next example is hydrazine, NH2, N2H4 or NH2. There are two lone pairs in hydrazine. So now these two lone pairs require 2 H plus ions for their complete neutralizations. So because of these two lone pairs, the N factor of the hydrazine is equal to 2, because one hydrazine molecule, it reacts with 2 H plus ions to give the corresponding for complete neutralization, right? So you'll get this type of ion on neutralization of one hydrazine molecule. equivalent weight of base is equal to, it equal to, formula is same, its molecular weight divided by n factor. Its molecular weight divided by n factor is a acidity of base. NaOH equivalent weight of NaOH, molecular weight of NaOH, its molecular weight NaOH. Sodium, we know that sodium atomic number 23, oxygen 16 plus hydrogen is equal to 1. So its molar mass become 40, and its acidity is equal to, only 1. So equivalent weight of sodium hydroxide is same as its molecular weight. Next example is calcium hydroxide. Calcium atomic mass is 14 plus 2 into 16. 16 is atomic mass of oxygen, 40 is atomic mass of calcium, plus 2 into 1, 1 is atomic mass of hydrogen. So total become 40 plus 32 plus 2, which is equal to 74. So equivalent weight of calcium hydroxide is equal to 74 divided by 2, which is equal to 37. Next example is equivalent weight calculation in case of hydrazine N2H4. N2H4 molar mass 2 into 14 plus 4 into 1. So 14 2s are 28 plus 4 32. So equivalent weight of hydrazine N2H4, we know that its acidity is equal to 2. So 14 2s are 28. Okay, 32 divided by 2. So which is equal to 16. Equivalent weight of hydrazine is equal to 16. Okay, so this is about an equivalent weight and N factor calculation in case of base. Now we'll move on. Next point, that is element. Equivalent weight of element is equal to its molecular weight, or specifically in case of element, instead of molecular we can use atomic weight divided by n factor. N factor is a valency in case of element. For example, in case of sodium, its n factor is valency in case of element. So sodium के case में n factor is equal to 1. Magnesium, calcium element n factor is 2. Aluminium n factor is 3. So in case of element, n factor is same as its the valency. So sodium, its equivalent weight is equal to atomic weight is 23, its valency is 1. So equivalent weight is same as atomic weight. In case of magnesium, let us find in case of magnesium 24 divided by its valency 2, so equivalent weight become 12. Aluminium atomic weight 27, its valency is 3 because 3 electrons are there in valence shell, equivalent weights become 9. And in case of calcium, 2 electrons in valence shell, so atomic weight is 40, 40 by 2 is 20. Okay, so by directly using the formula, we can easily calculate the equivalent weight of element. Next is equivalent weight of ion. Equivalent weight of ion. Equivalent weight of ion is equal to molecular weight of ion, molecular weight divided by n factor. So here n factor is charge on ion. So let us find n factor first in case of ions. For example, Na plus. If Na plus is given, then what is n factor? N factor is equal to charge. N factor is equal to charge, right? So Na plus, what is the n factor of Na plus? Its n factor is equal to Na plus, only one charge is there, so only magnitude plus 1, n factor is 1. In case of ion Cl minus ion, n factor is a mod of -1 become positive +1. If sulfate ion is given, then charge is -2. So n factor of sulfate ion is 2. If carbonate ion is given, then charge is -2. N factor is mod of -2, which is equal to. So for any ion, for example, next example is pyrophosphate ion P2O7-4. Here n factor is 4. The charge is -4. So n factor of pyrophosphate ion is equal to 4. So if any charge species is given, then n factor is same as a charge. So how to calculate here equivalent weight? For example, in case of suppose equivalent weight of magnesium 2 plus ion, equivalent weight of magnesium 2 plus. So its molecular weight magnesium 24 and the charge is 2. Charge is 2, so its equivalent weight is equal to 12. Next example is equivalent weight calculations in case of sulfate ion. Equivalent weight of sulfate. In sulfate ion, what is the molecular weight? Sulfate molecular weight is equal to 96 divided by n factor is 2 equal to 48. 48 is the equivalent weight of sulfate ion. So for any ionic species, if you know the charge on the ion and the molecular weight, then by using the formula equivalent weight of ion is equal to molecular weight divided by charge, we can easily calculate its equivalent weight. Next type of compounds are salt. Next type is salt. In case of salt, how to find n factor? Salt n factor of salt is equal to, it is equal to total charge on cations, total charge on cations or anions For example, NaCl. NaCl is a salt, and this NaCl, let us find what is the total charge on cation or anion. So NaCl, we know that on dissociation it gives Na plus Cl minus ion. So what is the charge here? Charge on cation is +1, right? So charge on cation is +1. So take mod only. A charge on anion is -1, -1. So n factor is 1. So n factor of NaCl is equal to 1. Next example is AlCl3. AlCl3 on dissociation gives Al3 plus ion plus 3Cl minus. Now here, what is the charge on cation? The charge on cation is +3, while total charge on anion is 3 into -1, which is equal to -3. So take a mod -3 for n factor calculation. So n factor of AlCl3 is equal to 3. Next example is aluminium sulfate. Al2SO4 of thrice, aluminium sulfate. Aluminium sulfate on dissociation gives 2Al3 plus ion plus 3 sulfate ions. So here, total charge, find total charge 2 into plus 3 plus 6, and total charge on anion 3 into this -2. 3 into -2 is equal to -6. So n factor of aluminum sulfate is equal to 6. Next example, calcium phosphate. Calcium phosphate on dissociation gives 3 calcium 2 plus ion plus 2 phosphate ion. 2 phosphate ions, right? So what is the total charge on cation? 3 into plus 2. 3 into plus 2, which is equal to +6. And phosphate ion 2 into -2 is equal to -4. Sorry, there's some mistake here. In phosphate ion, charge is not plus -2, charge is -3. So 2 into -3, 2 into -3 is equal to -6, and factor of calcium phosphate is equal to 6. Okay, because in any type of salt, the total charge on cations is always equal to total charge on anion. So while calculating the n factor, we'll either calculate the charge on cation or anion. Will because here we are taking only the positive value. as n factor. Okay, so we can calculate n factor in case of salt by calculating the charge on cation or anion. So we'll get a same answer. Next example is kernelite KCl MgCl2 dot 6H2O. KCl dot MgCl2 dot 6H2O, name of the compounding is kernelite. This salt on when added into water, it gives K plus ion plus 3Cl minus ion plus Mg2 plus ions and 6 water molecules. 6 water molecules remain as it is because water is a highly stable molecule. Partial dissociation only takes place. So here we are considering the total charge on cations or anions only. We are not calculating the charge which is present on water. So let us find here what is the total charge on cation. Plus 1 plus 2. So plus 1 plus 2 is equal to plus 1 plus 2. Total charge on cation is equal to plus 3. While total charge on anion is equal to 3 into minus 1 charge. 3 into minus 1 minus 3. So n factor of kernelite is equal to 3. Next example is similarly potash alum. The formula of potash alum is potassium aluminum sulfate K2SO4 Al2SO4 of thrice dot 24H2O. Now this potash alum on dissociation, what will happen? Let us find. It gives how many ions when added into water? It gives 2 K plus ion plus 4 sulfate ions, 4 sulfate plus 2 Al3 plus ions plus 24 water molecules. So what is the charge on cation here? Cation and anion. So anion, let us find first charge on anion, minus 2 into 4. So charge on anion is equal to 4 into minus 2 minus 8. And what about the cation charge? Total charge on cation 2 into plus 1, 2 into plus 3. So charge on cation is equal to 2 into plus 1 plus 2 into plus 3, which is also equal to plus 8. Magnitude is same, plus 8 minus 8. So n factor of this potash alum is equal to 8. So here also for equivalent weight calculations, we'll be using the same formula, like molecular weight divided by n factor. Okay, so let us summarize the n factor calculation part. N factor in case of acid, if the given substance is acid, then n factor is equal to its basicity. If the given substance is base, then n factor is its acidity. Now acidity means what? Number of OH minus ions formed per molecule of base, or number of H plus ions are required to neutralize one molecule of base. And in case of ion, n factor is equal to charge. In case of ion, n factor is equal to charge. In case of salt, n factor is equal to total charge on cations. Total charge on cations or anions. Total charge on cations or anions. And one more point, that is element. In case of element, n factor is equal to, it is same as a valency. Okay, so this is all about the today's session and factor and equivalent weight calculations. Thank you everyone guys. Thank you so much.